Think about a high school cafeteria. You walk in and you instantly know where everyone sits. The athletes are at one table, the theater kids at another, and the quiet students in the corner. The universe organizes itself in a very similar way. Look around you. Your desk, your phone, even the air you're breathing right now, it's all made of matter. That simply means anything that has mass and takes up space. And if you zoom in close enough, all of that matter is built from incredibly tiny, invisible pieces called atoms. You can think of them as the microscopic Lego bricks of our world. Inside an atom, you'll find a distinct center, or nucleus, surrounded by even smaller particles moving around it like a tiny solar system. By understanding how these tiny atoms are mapped out on one specific chart, we can predict exactly how all the building blocks of our world will behave. Let's go back to our high school analogy. Every student has a unique ID number. In an atom, that ID number is located right in the center nucleus. The core holds positively charged particles called protons. The exact number of protons acts as the atom's unchangeable ID. That proton count tells us exactly which element we're looking at. For example, if an atom has exactly 1 proton, it is the element hydrogen. If it has 8 protons, it is oxygen. The number of protons entirely determines the element. An atom with 8 protons cannot suddenly become carbon. Scientists don't write out long element names every time they work. Instead, each element gets a short, standardized profile box. This chart shows one of those profiles. Look at the number 1 at the top left of this purple box. This atomic number tells us the exact number of protons. Below that is a large H. This chemical symbol is a code for the element. These individual profile boxes act as the individual building blocks that stack together to build the entire master layout. This chart shows the complete periodic table, and the elements are not seated randomly. These highlighted horizontal rows are called periods. As you read across from left to right, the atomic number goes up by 1, meaning each element has 1 additional proton. Those vertical columns numbered across the top are called groups. Remember our cafeteria cliques? Elements sitting in the same vertical group belong to the same family, meaning they behave in highly similar ways. You have cliques like the shiny metals, which include iron and gold. You have nonmetals like oxygen and carbon. And all the way over in group 18, you have the quiet kids, the noble gases, which rarely react with anyone else. Just by locating which column an element sits in, you can instantly predict its personality and how it will react with others. When these different elements interact, they can join forces to make totally new substances. We call these combinations compounds. Take water, for instance. The formula is H2O, which means 2 individual hydrogen atoms combine with 1 oxygen atom to fuse into a single water molecule. Or look at everyday table salt. Its chemical name is sodium chloride. It is made by combining sodium, which by itself is a highly reactive metal, and chlorine, a reactive gas. When they team up under the right conditions, they form perfectly safe, ordinary salt. Elements can have vastly different properties when combined into compounds compared to how they act on their own. But why do elements in the same vertical column act like a clique? Think of it like teenagers in a group wearing similar jackets. Atoms have negatively charged particles called electrons. These electrons live on different energy floors around the center, which we call shells. Each of these floors has a limited amount of room for electrons. Elements sitting in the same vertical group have the same number of electrons on their very outermost floor. Since they have the same outer clothes, they react with others in the same way. This explains the uneven shape of the table. Because a new row only starts when a floor is completely full, the table ends up with gaps and jumps. This structure keeps elements with the same number of outer electrons perfectly aligned in those vertical columns. This chart is a map of the materials right in front of you. The computer chip running this video relies on silicon. The wires in your walls use copper. Your own body runs on oxygen and carbon. Think of the periodic table as a master map. It organizes every type of atom so we can understand their behaviors at a glance. If you remember 3 things today, make it these. First, protons are the ultimate ID badge. The atomic number tells you exactly what the element is. Secondly, the vertical columns act as families. They organize elements by their outer electrons, seating similar behaviors together. Third, elements act like cosmic Lego bricks, combining to form entirely new compounds with completely different properties.
You don't need to memorize all 118 elements. Once you understand how to navigate these rows and columns, you have a tool that helps you predict how the physical world reacts.